Hi everyone, let's continue with laws of radicals. So for example, if you had the square of the square root of x, how could you simplify that? Well, the square and the square root undo each other, and this does simplify to x, provided that x is not what? We only take the square roots of what kinds of values or numbers? Non-negative. Non-negative. Remember, if we have the square root of -1 in there, we're dead right there. Okay, don't mess with that. Don't go there. All right, so the square of the square root of x is x. That does work out, provided that x is non-negative. All right. Now, what about the cube of the cube root of x? Well, the cube and the cube root undo each other. We get x. Now, we do not take the square root of a negative number because that's not real, but can we take the cube root of a negative number? What's the cube root of -1? The principal cube root. It is -1. So this works out. And it turns out that this statement is in fact true. We're going to use this notation now. It's true for all values of x in the reals. So see this set notation? This is true for all values of x in the reals. This is true for all real x, even the negative values of x. All right. So what is number 12? Law number 12. The square of the square root of x is x. The fourth power of the fourth root of x is x, and so forth, if x is non-negative. That's a condition. Otherwise, we have a problem of non-real quantities in there. But if you have something like the cube of the cube root of x, like this, or the fifth power of the fifth root of x, that's x for all real values of x. So you see, there are differences between even roots and odd roots. And actually, you like odd roots better. I know I'm telling you how to think, but you like odd roots better because you don't have these special deals here. Now for law 13, let's consider this. What if we go the other way around? What if we put the power on the inside, the root on the outside? What is the square root of x squared? Now, if you know me by now, you might be thinking, is it x? Well, again, that's true if x is non-negative. But then you might argue, but wait, if x is negative, the square takes care of that sign issue, right? Okay, the square of a real value is never negative. That's true, but let's do an example here. What if x is a negative value? Okay, so if x is, for example, -3. This all works very cleanly if x is +3. Check it out. But what if x is -3? Let's see what happens here. All right, the square root of the square of -3. The square root of the square of -3. Please put, I'll put this in a dark red here. Please put grouping symbols brown here. Okay. Whenever you substitute or plug in, be prepared to put grouping symbols. Okay, the x is replaced by, in this case, parentheses, -3. What is the square of -3? The square of -3 is +9. All right? It's important you put the grouping symbols there because, and a lot of engineers mess this up. What's this? As it stands, what's this based on the order of operations? You could read this as -1 times 3 squared. But which comes first? Multiplication or exponentiation? The exponentiation comes first. It's -1 times 9. We get, in the end, -9. I get scared when I hear that engineers don't know that, okay? As this stands, the opposite of 3 squared, that's -9. With grouping symbols here, we end up with +9. Now, what's the principal square root of positive 9? That is going to be positive 3. But wait a minute. We start off with negative 3 inside here. 3 is not equal to negative 3. 3 is the what of negative 3? Well, it's the opposite of negative 3, but it's also the what of negative 3. 3 is the what of negative 3. It's the absolute value. So here's the rule for number 13. Again, the even roots are harder. Okay, the square root of x squared is not x in general. It's true for non-negative values of x, but in general, the square root of x squared is the absolute value of x. If you want this to be true for all real values of x, in general, this here is the absolute value of x. To make sure this is correct for negative values of x as well. So in general, the square root of x squared is the absolute value of x. If you want this to be valid for even the negative values of x. Although, if you consider the other way, well, if you consider odd roots, right? The odd root of the corresponding power. The cube root of the cube of x, that's straight up x. The fifth root of the fifth power of x, that's straight up x. In fact, it's wrong to put absolute value. Okay. For example, if x is negative 1 in here, you end up with negative 1 out here. It would be wrong to put absolute value. So again, the odd root case is easier. Okay, the odd root case is easier. That makes us happy. You like odd roots. You don't like the even roots so much because you have a condition as number 12, or in this case here, you need to put absolute value. In the bottom here, I have some warnings. All right. By the way, the rules for the root of a product, that's related to the idea of simplifying radicals. All right. Root 18 is root 9 times root 2, and that's 3 root 2. So basically, the 9 factor in the 18 pops out as a 3. So that's the idea of simplifying radicals. And I do a review of some fallacies. Do not think that this is equivalent to that. Same for differences. And remember, we're keeping things real. Don't mess with things like that for now. Okay. And again, you like odd roots. Even roots, they can mess you up sometimes. You might need conditions, such as the non-negativity condition, or you might need absolute value. Next up, we're going to express expressions in different forms. Radical form, exponential or power form, fractional form. Next time.